Okay, when you're doing a complicated integration by parts problem, the hard part usually is learning how to organize your work because there's a lot of algebraic expressions floating around. I'll just mention that one of the guidelines for integration by parts for setting the value of u is this memory device called lipit. It's also sometimes called LIAET. But L stands for natural logarithm, I inverse trig, P polynomial. If you use the A, it's algebraic, E for exponential, T for trig, and you use U, set U in this order. And this doesn't always work. These are just guidelines. So the way I like to do it, I like to ignore the limits of integration till the very end, and I would move this 18 out front. So I'll call this integral, this indefinite integral, I as x minus 1 the quantity squared, e to the minus 3x dx. Okay, and if we use lipit and go down this row or column, P is the first thing that we run into. So that means let's try to set U to x minus 1 the quantity squared. So du is 2 times the quantity x minus 1 dx. And dv is everything else except u, a indefinite integral of everything else. So dv would be the indefinite integral of e to the minus 3x dx, and the antiderivative v would be minus 1/3 e to the minus 3x. Applying the formula for integration by parts, we've got u times v, so that's negative 1/3 e to the minus 3x times x minus 1 the quantity squared, minus v du. So here's v, and here's du. So what ends up happening is this 2 times negative 1/3 is negative 2/3. If we move that out front, it becomes plus 2/3. And then we've got the definite integral of x minus 1 e to the minus 3x. So we need to evaluate this indefinite integral, which I've labeled I sub 1. And over here is I sub 1. And then using letters u and v, then it's a good idea to put some subscripts. So if this is u, these are u sub 1 and dv sub 1. I won't go through all of this. I'll let you look it over. But right here, when we apply the formula for integration by parts, we still have to find the antiderivative of e to the minus 3x dx, which is negative 1/3 e to the minus 3x. So here's the value of I sub 1, and that's what we're going to substitute in here. So that's what I've done over here. Here's I again with 2/3 times what we found out I sub 1 to be. And if we distribute this 2/3, this is what we get. And oh, by the way, I wrote down what it is we still have to do after we've evaluated the antiderivative for I. We have to multiply by 18. So here's 18i. And then we're going to evaluate it from 1 to 2. That means put 2 in for x, minus put 1 in for x. So I'll let you look over what happened here. But there's your final answer, an exact answer. If I go to board 2, this is from Desmos. Here's the definite integral evaluated as 0.03829, blah, blah, blah. Here's before I distributed the 18 or multiplied by 18, but I did evaluate from 1 to 2 to reach this point. And here's the simplified version of that. 4e cubed minus 34 all over 3e to the 6th gives us the same decimal approximation. So that's your exact answer right there. At least one form of it. Okay, there you go. Hope that helped. If you have any questions, post a comment.